Welcome back. We're going to do a little more division-like problems today. Our goal is all about interpreting the quotient. Basically, today's lesson is looking at real-life problems and saying, what are we really looking for in an answer for this problem? Sometimes you have to look a little higher than the actual answer, a little lower, or look for the exact answer. That's what we're going to work on today. So please write down today's date along with, or today's goal along with today's date and page number before moving on. Here is your warm-up. I want you to go ahead and divide these problems. Do your best. Remember, if you see a decimal, you got to move it, and whatever movements you make on one, you got to make on both. So here are the results of your warm-up problems. I showed how I rewrote them before I actually divided them. I forgot to write the decimal point would be right there. Decimal point would be right there. Decimal point would be right there, to be able to solve these. So first one was 5 and 88 thousandths. Number 2 was 1 and 26 hundredths. Number 3 was an even 45. And number 4 was 5 and 9 tenths. Hopefully I got the same answers. All right, let's get into our new stuff today. So here's an example, and I thought I'd show this one because it talks about slime, and I know how much you guys like making slime. Okay. So in science lab, Ken learned to make slime from cornstarch, water, and food coloring. He added 87 hundredths kilograms of cornstarch, and the recipe for one bag calls for 1,500 kilograms. So find the number of bags of slime Ken can make. So we know we need to divide, but we're going to have to determine how many bags are actually able to be made from this stuff. We can see that the recipe is a lot smaller than the full recipe, so how could we find out what the number of bags would be to solve this? These are the kind of problems we're going to deal with today. Not the slime, but the division part of it. So here's an example of interpreting the quotient, and you'll probably want to determine what you think is important to write down from this, but you should write down something. So it says, suppose Mark wants to make bags of slime. Here we go again. If each bag of slime requires 15 hundredths kilograms of cornstarch, and he has 1.23 or 1 and 23 hundredths of kilograms, how many bags of slime can he make? Well, obviously we're trying to make groupings, and whenever you deal with groupings, that means that we're dealing with division. So really what we're doing is we're trying to divide 1.23 and see how many times 15 hundredths goes into that. So I have a visual here of what it would look like, but let me show you mathematically what this all kind of looks like. So remember, if we see that we have two decimal point place values, we got to move them both equally, so twice. So now we're looking at how many times 15 really goes into 123, and if we have any remainder, we'll put the decimal. So we know that 15 won't go into 1, 12, but it will go into 123. Now, I know it'll go in 8 times because that's the information I see here. So I put the 8 above the 3, and 8 times 5 is 40. Carry the 4. 8 times 1 is 8, plus 4 is 12. So when we do this, we're left with a remainder of 3, and we bring down the 0. So now we got to see how many times 18 goes into 30, and that would be twice. 15 times 2 gives you 30. So when the question says how many bags of slime can he make, Mark can actually make 8.2 bags. But think about that. If you're going to make, the question says how many bags, okay? It doesn't say how many partial bags. It doesn't say how much total. It says how many bags. Now, interpreting this, you can see that you can't give 2/10 of a bag. So really, Mark can make 8 bags of slime. That's our final answer. Okay, so our quotient here shows that there's just not enough to make 9 bags, and a little more than 8, you can't get rid of partial part of a bag. So really, with having 1.23 kilograms of cornstarch, there's only enough to make 8 whole bags. So your answer here would be Mark can make 8 bags of slime. All right, let's get moving. So here, I'm going to do number 4, and then you're going to do number 7. So number 4 says there's 454 thousandths kilograms of cornstarch in a container. How many containers can you make if you have 28 thousandths kilogram portions? So again, this is one of those where we're going to have to divide. And if we look at it, we can see both have 3 decimal point place values that we got to move equally. And when we do that, we're left with 28 divided into 454. Decimal, decimal, just in case. So when we look at this problem, we see that 28 won't go into 4, but 28 can go into 45, and that would be 1, because 28 is just too big to be able to do twice. So when we subtract here, we know we're going to make 15. We're going to borrow here, so that becomes a 1, and you're looking at 17. Then we're going to bring down the 4, and we're going to see how many times 28 will go into 174. And the closest I can actually come up with, just to kind of keep it going, is 6. 6 times 28 gives you 168. So now I can tell that I'm going to be left with a remainder of 6. And I could keep going, but the question again says how many portions are in one container. I'm not going to put partial amounts of containers. It's going to be just the whole number here. So this is one where we interpret it as 16 portions. Okay, we're not even going to worry about the extra portion that you see there. Go ahead and solve number 7. Come back when you're done. Make sure you try to interpret this as best you can. All right, for this one, you probably saw that Nick is going to have to buy 3 packs of thank you cards. Because when you start dividing it, you see that 6 goes into 15 twice, and you're going to end up with a little remainder. You end up only getting 2.5 containers. Well, I've tried going to the store to buy half of something because I didn't want to buy all of it. People just look at you weird. So you can't buy half of a pack, so he would have to buy 3 packs. He'll have more thank you notes than he needs, but at least he'll have the minimum amount of packs that he could buy for it. So hopefully you got that one right. All right, so here's another problem. And this one we're looking at that there's 237 students in the 7th grade. Mr. Jones buys rolls of film that have 36 exposures each. So how many rolls will he need to take every student's picture? Well, really what the question is asking is how many rolls is he going to need to take the pictures? So again, this is one of those scenarios where if you had part of a roll, you know that that's not enough and you'd probably have to round up to the next available whole number. So that's exactly what happens here. When you try to divide 36 into 237, you'll see it goes in 6.583333. It just keeps repeating. Well, again, Mr. Jones can't go buy 6 rolls and then cut part of a roll apart. So this is a scenario where he would have to buy 7 rolls of film. So this is just another example to look at where your thought on the correct answer has to be a little different than just giving the exact amount, because that wouldn't work. Here are 2 problems, and I want you to try both of these problems, and then we'll see how you do and how well you interpret this. Good luck. Come back when you're done. So both of these had a different way of interpreting it. So what you can see is that in the first one, when you did the math, you realized that you only had 7.2 bunches. That wouldn't be enough to make a total set, so you'd have to round it up to 8 bunches that would have to be purchased. Okay. For the second one then, you end up with this long decimal and you realize you don't have enough seeds for every kid individually, so that's why we would have to say 5 packs. So this is one where you round down. Number 5 is where you round it up. Number 8 was when you round it down. Hopefully you got those answers right. Now, in example 3, we're going to be looking at problems where having the exact answer is what you're looking for. So it says Gary has 42 and 25/100 meters of rope, and if he cuts it into 13 equal pieces, how long is each piece? Well, you have so much rope, and you're going to cut it so many times, you know that already. So the question is really asking how long is each of those little pieces going to be? So we have to divide 13 into 42.25. What we'll find out is 13 goes into 42 3 times, and here I'll actually show you. 13 into 42.25. So we know that 13 will go into 42 3 times. That's 39. So we have a leftover of 3. We bring down the 2. 13 will go into 32 twice. That's 26. And we have a remainder of, let's see, 4, 5, 6. And we bring down the 5. And 13 goes into 60 evenly 5 times. So then we're left. So each piece is going to be 3.25 meters long. So that's given away by just seeing that you're looking for the exact answer. So we're not going to round down, we're not going to round up. That's exactly how long each piece will be when you cut it. All right, so that you're not overwhelmed too much, I want you to just do number 6 on the top. So Bobby's goal is to run 27 miles a week. If he runs the same distance for 6 days, how many miles would he have to run each day? So you're going to have to probably find an exact answer for this. Good luck and come back when you're done. And you probably saw that it would be 4.5 miles a day that Bobby would have to run based on your work. So this one you need to know exactly what it is so that he meets that goal of 27 miles. That's why we looked for an exact answer that ended up with a decimal. Okay, cool. So go ahead and work on your box of thought today. It says, tell how you would interpret the quotient. A group of 27 students will ride in vans that carry 12. How many vans are needed? I'm not asking you to solve it. I'm asking for you to explain how many vans are needed. Explain how you come up with your answer. And here's your, oops, sorry, I forgot we have one less set of notes to kind of help you determine what you're looking for. So whenever you're dealing with questions that say how many whole groups can be made when you divide, that would mean that you're dropping the decimal or rounding down. Whenever you have how many whole groups are needed to put all the items from a dividend into a group, that means that you're going to have to round up to the next available number. Where if it asks for an exact number, that means you're going to find equal, exactly what you need. Make sure you have this down because this will help you in determining a question, what kind of interpretation you need for that division problem. All right, your quiz today is just 2 questions. You're going to have to figure out which way you're going to interpret the answers. If it's going to be an exact answer, if you're going to have to round up, you're going to have to round down. Good luck. Okay, that's it for today's lesson. Hopefully you didn't find it too hard. It's one of those that you really have to use some more thinking, some mental thoughts before you give just an exact answer, because it's not always going to work out that way. So that's it for today. We'll see you next time. We have one more lesson for this unit, and that one's going to be on trying to deal with equations, finding inverse operation and all that stuff. All right, see you later.